I'm going to solve the second problem of the final exam of electricity and magnetism that says like this. A 1 microfarad capacitor charged at 50 volts and 2 microfarads, 1 charged at 20 volts are connected, and the 2 microfarads charged at 220 volts are connected with the positive plate of one connected with the negative plate of the other. What is the final charge in the 1 microfarad capacitor? So here we have our capacitor charged here, and here we have our capacitor charged here. Then both capacitors are connected here in series, capacitor 1 and capacitor 2. So as they are connected in series, we will have here that the charge will be the same one. For the total charge of the initial capacitor will be equal to the final charge of itself, the final total charge. Okay, once we determine this, we want to work with the initial total in terms to determine the final charge of the first capacitor of this one. Okay, so we know that for the initial total charge, we have the sum of both charges. So the initial charge 1 plus the initial charge 2. This is equal, the charge is equal to the capacitance times the voltage. So here we have capacitance 1 times voltage 1 plus the capacitance 2 times our voltage 2. And this is how we determine the initial total charge. Okay. Then what we can determine also is that our final charge of 1 will be equal to the final charge in 2 because they are connected in series. Okay. Once we determine this, we can determine the value of the charge in 1. So the final charge in 1 will be equal to the half of the charge, the final charge. Why a half? Because here we only have 1 microfarad and here we have 2 microfarad, so it's half of the charge. So this will be exactly the same as saying that it's half of the charge itself times the initial, because we know that the final charge is equal to the initial charge. So here it's equal to the initial total charge. Okay, and so this is equal to this part in here is equal to this part in here. So we can say that this is equal to half of times capacitance 1 times voltage 1 plus capacitance 2 voltage 2. Okay, and then we only have to substitute here our values that are given by the problem. So we have the half of capacitance 1, that is 1 microfarad, but it's using it as only farads. It's equal to 1 times 10 to the minus 6. Our voltage 1, it says that it's charged at 50 volts. So here we multiply by 50 plus the capacitance 2 that are 2 microfarads. So it's 2 times 10 to the minus 6 farads times our voltage 2 that is 20 volts. Okay. So once we have all these values, we only have to put it into the calculator, and we will obtain that our total force in 1, that is this one, the one we are using, is equal to 4.5 times 10 to the minus 5 capacitors. So this is the result of all these operation, okay? And this is how you solve this problem.